Hi everyone. So we will be starting with the session now. So hi everyone. This is Manish Nath from Hex-Star Universe, and I am going to be your host for today's session. First of all, thank you everyone for joining us today. Now our topic for today's session is rocket propulsion. And to enrich us on this topic, today we have none other than Ms. Vani Sadadiwala with us. She is currently pursuing her master's in Aerospace Engineering from the University of Manchester, and her specialization is Aeronautical Engineering. We are really glad to have her here with us today. So, without any further ado, I'd like to request Ms. Vani to proceed to this session. Thank you, everyone.
Hello everyone, I am Vani, and as I am introduced, yes, I'll be talking today about the concepts of rocket propulsion and how rocket propulsion deals with the trajectory motions as well. As a part of my introduction, I would like to tell you that I have pursued my BTech in Aeronautical Engineering from Manav Krishna International University, Faridabad, Haryana, India. And currently, I am placed in UK and I'm pursuing my master's in Aerospace Engineering. Also, I have carried out many projects as an intern at DRDO, India, which is in the Bangalore division, and the Center of Airborne Systems for Collision was my preparatory, and the development of antennas and also radars have been conducted by me. So let's get started with the session. Okay, so let's talk about rocket propulsion. So today I'll be discussing about certain major topics which are very much important from the rocket science point of view, and it starts with the introduction, followed by history of rockets, methods of modern rocket propulsion, different nozzle configurations, rocket staging, and hence it is concluded by a summary. As you can see in this photograph, there are three major components of a rocket. It includes nose cone, fuselage, and fins. As you can see on the screen, that the foremost cylindrical part is the fuselage, which is the main body of the rocket. The tip is the nose cone, and the following part is the fins. Okay, so you must be wondering that what is rocket propulsion? It is basically a type of jet propulsion which produces thrust, which is produced by ejecting the matter, or you can say propellant, which is stored inside the vehicle which is to be flown. So, for example, if you consider a photograph that is a rocket as shown in this picture, it includes two types of forces, that is forces on gas and forces on rocket. This is also considered on the basis of Newton's third law of motion. So, for example, if I talk about forces on gases, the matter which is stored in the rocket is also known as propellant, which is composed of chemical gases. And as there are certain forces on these gases, it is certain sort of action reaction, and due to this action reaction, it moves the rocket in forward direction. So, if any kind of jet propulsion device which produces certain amount of force, which is thrust here, it is produced by ejecting the matter, which is known as propellant, stored inside the vehicle, which is in the flying condition. So, in this scenario, it is basically the action of forces on a gas, and the reaction is the force on rocket, which moves the rocket in the forward direction. Also, if I talk about the second division, that is the duct propulsion, it is basically a type of jet propulsion which uses the air breathing engines. So it includes the categories such as ramjets, turbojets, scramjets, etc. Also, the main element of this kind of air breathing engines is the air. So basically, there are four major procedures in turbojet engines, that is inlet, compressor stage, combustion chamber, and the last one is the exhaust chamber. So if we consider a section of air intake, air is sucked through the air intake, which then moves to the blades of the axial flow compressor, in which the air is pressurized and hence the pressure is increased whereas the volume is decreased. Further on, if we move to the combustion chamber, there are certain kinds of fuel spray manifolds which injects the fuel or which sprinkles the fuel into the mixture and compressed into the mixture, which forms a compressed mixture and fuel of the composition, and hence it moves ahead to the turbine. In that turbine, due to the movement of the rotor and stator blades, the air is flown out through the exhaust duct with high amount of velocity and highly pressurized manner. So in this condition, it basically deals with the working of the intake air geometry, also the turbine geometry, and when it comes to the nozzle configuration, there are many kinds of nozzle configuration, which include CD type, that is converging, diverging, or only converging, only diverging, etc. It is later discussed in the forward part of the section. So I hope now you are clear with the concepts of what is rocket propulsion and how it works. It works on the Newton's third law of motion, that is every action has equal and opposite reaction. And when it comes to duct propulsion, it basically uses air as a major part of the working process. Okay, so let's look back into the history of rockets. There are three early rockets which were introduced beforehand, and since then the history created. Okay, so if I talk about the first one, as you can see in the photo, it shows a pigeon which was created by Archytas and he named it as a wooden bird. So who was Archytas? He was a normal person who lived in the city of Tarentum, and he designed one of these devices which successfully employ the principles which are essential for the rocket flight, and he named it as a wooden bird. As you can see in this picture, it states that this bird is suspended on a wire and it is propelled using the steam. So it means in this kind of wooden bird creator and in this kind of wooden bird characteristics, you can see that the escaping steam is considered as a propellant and it is stored in the and the steam is used as a direction to flow the rocket in the forward direction. So as you can see, the pigeon was used as the action reaction principle, and this pigeon was designed just to check the characteristics if the action reaction principle works based on Newton's law or not. As this idea was not at all successful during the history, so it was eliminated and it was then used by the following concept, that is the heliophiles, which is shown in the second photo. So about 300 years after the development of Archytas wooden bird, Alexandra from Greece invented a similar rocket which is known as heliophile. It is basically the concept of Newton's third law of motion, but it was slightly changed in the manner of heated cattle and also with the steam which rises through the tubes. So this photo displays that there are certain major components, that is directional nozzle, which is in the L shape. There is a sphere which is caused by the steam exhaust. There is one vaporized in heated kettle, and also there are certain tubes through which the steam rises up in the sphere. So this kind of geometry uses steam as a propulsive gas. Again, as we if we compare the first and the second geometry, both of them uses the steam as a propellant, or propellant which is also known as the matter stored in the combustion device. So yeah, he mounted a sphere on the top of the water kettle. The fire below the kettle was turned, it heated the water which generates the steam, and the steam rises through the tubes. This steam exhaust causes the sphere to move in the rotational motion, and hence the two L-shaped tubes, as you can see on the right and the left side, are allowed, and they release the gases to escape, and this gave the thrust to the sphere, and it caused the rotation motion of the sphere. This kind of concept was introduced just to check that if forces on gases is considered as an action, so what can we see as a result of the forces of reaction. And as you can see, if we consider the case of the steam, it caused the sphere to move in the rotational motion, and hence the Newton's third law of motion was satisfied. So for the third type, after many kind of failure attempts, Chinese invented these bamboo stick rockets. So in the very first century AD, Chinese had a simple form of gunpowder made from saltpetre, sulfur, and charcoal dust. They basically created the explosions during the festivals, and they used this bamboo stick concepts with this mixture, which I stated, that is saltpetre, sulfur, and the charcoal dust. Some tubes failed to explode, and they didn't propel by the gases, whereas other tubes generated spark, and they produced some sort of burning sensations using the gunpowder solution. Soon after lot of failed and unwanted attempts, they discovered that this gunpowder tubes could launch themselves just by the power produced by the escaping gas. So in this condition, the matter was used as a gunpowder, and it helps in propelling the rockets in the forward direction. Hence, after this bamboo rocket invention, the true rocket was born, and this is how we use the logic of Newton's third law of motion, that is action and reaction principle, in our rocket propulsion idea. So there are various kinds of methods of modern propulsion. If we look on the diversion of the rocket propulsion based on the types of propellants used in motors, so it can be considered that there are majorly five types, that is solid propellant rocket, liquid propellant rocket, hybrid, electric, and nuclear. So as you can see in these bifurcations, these rockets are totally divided on the basis of type of propellants used in the rockets. So let's first focus on the major parts of the rockets in detailed manner. That is starting from nose cone. It has payload system and guidance system, which is included in the nose cone geometry. The second part is the fuselage part, which consists of three major components. That is a fuel device, oxidizer device, which is bifurcated, which is also known as the frame of the rocket. Fuel and oxidizer basically gets involved in solid propellant, liquid propellant, and every kind of propellant type of rocket propulsion. Also, if we consider some extra mechanical devices, which are pumps, nozzle, which helps the flow to occur in normal and highly pressurized manner. If we talk about fins, they are it comes under the major part of the rocket part. Also, if you look out this blue section, that is starting from the fuel chamber and it ends at the nozzle, this is included in the propulsion system. So as I explained, that the intake, intake, compressor, combustion chamber, and nozzle. These four major geometries constitutes the type of propulsion system, and the whole pictorial representation demonstrates the structural system of the rocket. So basically, the rocket is the inclusion of payload system, guidance system, propulsion system, and structural system. So we'll look deeply into the matter of propulsion system. Okay, so if we talk about solid propellant rocket, the major constituent is fuel, which and oxidizer, which are mixed together. So generally, if I talk about fuel, yeah, so generally, if I talk about the type of fuel and oxidizer which are taken in this kind of solid propellant rocket, so as you can say that it is a solid type, so the fuel and oxidizer are in the solid stage. This photo deals with the major constituents of the solid propellant rocket. So the first part is the fuel and mixture oxidizer. The second part is the combustion chamber. The third part, or the major throat section area, And the fourth part is the nozzle, which resembles the exit area. So this is a type of rocket with rocket engine that uses solid fuel and solid oxidizer. In this type, the fuel and oxidizer are mixed together and are pegged in the solid cylinder. So here the solid cylinder is this kind of geometry which is shaped in the triangular format. When the mixture is ignited, the combustion takes place on the surface of the combustion chamber. So in a kind of solid propellant rocket, the surface combustion occurs and the fuel and oxidizer mixture are burned through the flame front, which is the triangular part. The solid propellant charge is also called grain and it contains all the chemical elements for the complete burning. This whole geometry, including this triangular frame front and the combustion chamber, is known as the grain, which stores the fuel and oxidizer mixture. Once it is ignited, it usually burns at a predetermined rate and all the exposed surfaces of the grain. So this internal cavity, which I termed as grain, is burned and is consumed at the supersonic nozzle impact. So if you consider the process of the burning of fuel and oxidizer mixture, it then moves to the throat area, and this results in the hot gas flow through the supersonic nozzle at the exit, which imparts a high velocity thrust. There are no feed systems or extra mechanical devices attached to this kind of solid propellant rocket. So the motor combustion only proceeds until all the propellant is burned on the surfaces or all the matter stored in the flame front area is consumed. So this kind of flow, which is imparted through the nozzle, helps in production of thrust, that is high velocity thrust. And at the end of this process, it is mandatory to check that all the amount of propellant which is present in the flame front is occupied, and then the process starts once again. So this also follows the Newton's third law of motion. Okay, so if we consider the types of burning which happens on the surface of the cylinder, it is basically of two types, that is restricted and unrestricted. So first of all, let's see the solid rocket propellant motor, which includes grain. This includes the flame front property as well. Also, it is occupied by the casing, which is known as inhibitor or lining, which basically protects the grain from any kind of damage or dents. Third is the ignition charge. Fourth is the seal, which is near the throat area. And the fifth is the nozzle, which imparts thrust. So if we talk about the restricted burning, it is usually throughout the whole cylinder. So this is the kind of geometry which is used in the restricted burning concept. So the lining is also known as the inhibitor, which protects the grain covering, and also it protects the whole cylinder from getting any kind of damage or effects. So if we consider this restricted burning case, the burning occurs in the whole cylinder, and the grain which stores the propellant allows the burning and the consumption of matter throughout the whole cylindrical area. This kind of restricted burning has two major characteristics: that at the end of the process, only low thrust is obtained and it burns during a long time of period. So there are two major characteristics, that is low thrust and long burning. If we talk about the unrestricted area or unrestricted burning consumption, it deals on the only surfaces of the cylinder. It means that there is a washer kind of geometry, or you can say that it is a different kind of chamber which is inbuilt in this kind of cylinder, which allows only the burning to happen on the surface and not throughout the whole geometry. This results into two kind of characteristics, that is high thrust is obtained, which is in the short duration of time. So majorly unrestricted burning is considered due to the impart of high thrust and comparatively short time of burning period. If we talk about the second type, which is the liquid propellant rocket, this deals with the liquid propellant, which consists of liquid fuel and liquid oxidizer. So the fuel and oxidizer are in liquid state of matter. This kind of liquid propellants are fed under pressure from the tanks into the combustion chamber. So this kind of rocket deals with different fuel tank and different oxidizer. If we look back into the solid propellant rocket, there was a combination of fuel and oxidizer mixture used in a single tank. But if we compare it to the liquid propellant, there are two different tanks used for fuel as well as oxidizer. They are highly pressurized using the pump and they are injected in the combustion chamber, whereas the turbine works for the purpose and the valves which are used are the part of the complex mechanism or complex mechanical systems. So the liquid propellant here consists of a liquid oxidizer and a liquid fuel. For example, in this case, we can consider the liquid oxidizer as a liquid oxygen and the fuel can be considered as a liquid kerosene. This type of propellant is known as bipropellant because it uses two kinds of it uses two kinds of matter, that is liquid fuel and liquid oxidizer. But if we want to term a monopropellant, it is basically a single liquid that contains both oxidizing fuel. So it decomposes into hot gases when properly catalyzed and when properly fed under pressure. This kind of rocket systems are generally used in vehicles with large amount of propellants and which want to produce higher amount of thrust for space launch vehicles. So in the thrust chamber, you can see that the propellants react to form hot gases which are accelerated and ejected at high velocity through supersonic nozzle and hence imparting momentum to the vehicle. Some liquid rockets permit repetitive operation and hence can be started and shut off at the will. So there is no as such involvement of continuous cycle and you can easily operate at the start, at the end of the will. Also, if you talk about a liquid propulsion system, there are certain parts which includes valves, complex feed mechanism, pumps, turbines, chambers, which are the supporting devices to this kind of rocket engine. The major characteristic of using liquid as a part of propellant system is that it has high density. So in order to reduce the amount of storage capacity, this kind of propellant system is highly considerable. Okay, so the third type is the hybrid propellant rocket, which basically deals with the usage of both solid and liquid as a propellant. So in this condition, if you take an example of a liquid oxidizing agent which is injected in the combustion chamber filled with the solid carbonaceous fuel grain, this chemical reaction occurs and also it releases the combustion of hot gases. So as you can see in this picture, there are certain major kinds of parts which are used in the hybrid propellant rocket. The first is the pressuring valve. It is followed by the regulator. The third part is the liquid oxidizer, where the oxidizer is stored. Fourth part is the valve. And the fifth is the combustion chamber, which injects the oxidizer here through the sprays. And the last is the nozzle, which imparts the thrust. So this kind of rocket consists of a pressure vessel which consists a liquid propellant and the combustion chamber containing the solid propellant. And the valve is taken into consideration for isolating the liquid oxidizer and the combustion chamber. So when thrust is desired, a suitable ignition source is introduced in the combustion chamber and this valve is opened, which helps the liquid oxidizer to flow in this combustion chamber. And then after the oxidizer is injected through the spray, and here the combustion occurs, which helps in imparting the thrust at higher velocities. This kind of hybrid propellant is basically compared to the liquid type, it states that you can only use solid you can use liquid kind of characteristics in liquid propellant, but when it comes to hybrid you can have a combination of solid or liquid also. So in such cases it is generally advisable to use a solid carbonaceous fuel grain so that the fuel is in solid form whereas the liquid oxidizer is in liquid form. So in these conditions, many liquid oxygen is also taken into consideration. The last is the electric propellant, which is generally the source of many kind of electric powers, that is nuclear, solar batteries, and also it is physically separated from the mechanism that produces thrust. So this kind of propellant rocket has an individual separate database for the production of thrust. This type requires heavy power sources. If you look into this type of rocket, it is generally considered that the thrust is very low. So the amount of thrust produced after the types which are carried in this kind of rockets is very low, and hence it is not recommendable, but it is a major type as well. So there are three bifurcations, that is electrothermal, electrostatic, and electromagnetic. Electrothermal is a type in which propellant is very much heated in a vigorous manner through an electrical power source, and the hot gases which are obtained is then thermodynamically expanded through the turbine and accelerated to the supersonic velocities through an exhaust nozzle. Whereas if you consider the state of electrostatic, in this kind of electrostatic working, the fluid is ionized to high ions category, and then they are electrically charged and expanded and then accelerated to high velocities. For the electromagnetic part, if you look into the concept of plasma state, that is, an electrical plasma is accelerated, which is generally between the interaction of electric fields and magnetic fields, and then after they are ejected through velocities. So, talking about the electrothermal, electrostatic, electromagnetic, or they all have different kind of propellant matter storages. That is, electrical charges are used in electrothermal. In electrostatic, ions are used, and for the electromagnetic, there is certain kind of plasma state developed due to the combination of electric fields and magnetic fields. So, in this kind of propellant characteristic, the thrust obtained seems to be very low. The major components includes here the major components which are included here are the propellant gases mixture cylinders, the valves, the chamber which is connected to the cathode. Also, there is a covering which is connected to the annular anode. There is a nozzle which is used for imparting the thrust, but it is generally of low value. And there are certain arc sections, that is the arc between cathode tip and anode tip, for generating the spark in order to burn the mixture of propellant gas, and also in order to ionize the ions which are used in the electrostatical concept. So if we compare all these three types, that is electrothermal, it is noticed that all the gases which are dynamically expanded generally are accelerated to supersonic velocities through the exhaust nozzle in all the three categories. And the last is the nuclear propellant rocket. So, as you have heard about the chemical reactions, that is fission and fusion reactors, which are used as an energy sources. So, these are the two types of nuclear energy source that have been considered for delivering heat to the working fluid. In this case, the working fluid is the liquid H2, which is shown in the figure, which can be expanded in the nozzle and thus accelerated to high ejection velocities. So, this is the type of fission and fusion reactors which are used as energy sources. So, in nuclear fission, the basic working is the heat is generated by the fission of uranium. So, if you consider a nuclear reactor core, it consists of uranium composition, which is heated and which is carried out by the fission process. And if you talk about the fusion, it is the alternative way to generate energy in order to provide heat to the working fluid. So these are the fission and fusion reactors in which the nuclear core reactor plays the important role of helping out these reactions, that is fission and fusion. So both are the extensions of liquid propellant rocket engines. This category falls under the subcategory of liquid propellant engines, but in nuclear fission reactor, heat can be generated using the fission of uranium, and hence this kind of heat which is generated can be transferred to the working fluid, and the fluid can be heated and later on is used for imparting higher amount of thrust. So there are certain kind of complex mechanisms involved here, which includes the addition of components that is shield to protect the nuclear reactor core, the control rods that are the mechanical rods which helps in the generation of heat due to the process that is fission and fusion. Also there are certain valves which are used for pressurizing the tubes and chambers. There is a pump which allows the liquid H2 to flow without any kind of hindrance or disturbance, and the turbine gas line which determines that the heat generated and the working fluid is in a stable state, and it allows the expansion of working fluid as well. And last is the nozzle which imparts the flow at a higher velocity. So here we cover all our five major types, that is solid, liquid, nuclear, electric, and hybrid. So basically, they are just the bifurcation of the types of they are basically just the bifurcation based on the types of propellants used. That is, if we rewind all our slides, we can say that the solid type has fuel and oxidizer as a mixture together in only single chamber, which leads to the ignition of this mixture in the combustion chamber, that is the inclusion of flame front area, and this results in the hot gases flow through the nozzle to impart thrust. In such kind of system, there is no need of any mechanism or any extra kind of valves. So this is not included in the category of mechanical complex system. There are two types, that is restricted and unrestricted. It basically follows usually throughout the cylinder if we talk about the restricted, and if we talk about the unrestricted concept, it occurs only on the surfaces of the cylinder. The second type is the liquid, which uses both the fuel and liquid oxidizer in the liquid state. The only reason to use such kind of propellant rocket is that liquids have high density, and so the storing problems can be minimalized if we use such kind of rockets into consideration. There are various mechanical parts include which states that valves, pumps, turbines, chambers are very much required for the working of such kind of rocket motors. The third is the hybrid, which uses solid and liquid as a propellant. And in this condition, pressure vessel is major, which consists of a liquid propellant, and it allows to flow through the pipeline into the combustion chamber, which allows the oxidizer to be injected using the fuel sprays. The next is the electric propellant type, and basically it deals with the heavy power sources. It is not at all advisable to use such kind of motors if you are expecting a heavy amount of thrust at the end of the process, because the thrust obtained due to the reliance of heavy power sources is very low. And the last is the nuclear propellant rocket, which uses the chemical composition and the chemical processes, that is fission and fusion reactors, which are used as an energy sources. In such conditions, the uranium is bifurcated using the nuclear fission and nuclear fusion, and both are opposite in the way of generating the energy which is required to provide the heat to the working fluid, which is here the propellant characteristics. If we talk about certain nozzle configurations, there are three major types, that is bell, cone, and annular. So the main agenda of using bell is that it is a minimal weight type of nozzle which helps in obtaining maximum performance. For the cone type, the flow is axial throughout the conical type of nozzle. And for the annular type, it is generally least employed due to greater complexity because of the types of mechanism systems used in this type. So bell is further bifurcated to the contoured and CD part. Cone is further bifurcated into linear and conical. And the third is the annular, which is divided into spike, aeroplane, plug, and expansion. These are the types, but which are not generally used due to the complex and greater complexity, and also due to the unwanted configurations which makes it impossible to be employed in heavy working devices. If we talk about the conical nozzles, which states that the flow is very much axial throughout the working. So the walls of the conical type diverge at the constant angle. So the angle of divergence is very much constant here. If we consider a smaller angle, it will produce greater amount of thrust and hence produces specific impulse. The flow in such kind is totally axial, and this kind of conical nozzles are used in early rocket applications because of simple consideration. So you just need to consider and take the smaller angle into consideration. And if you use a smaller angle, it will help you to produce the thrust in greater amount, and the specific impulse is also increased, which results into the heavy amount of thrust. For the bell nozzles, there are two types of shapes which are considered, that is the throat area and the nozzle exit configuration. So there are two sections. So first, if we talk about the throat section, it diverges at the larger angle. So this is a contradictory statement in comparison to the conical nozzle, that in this kind it diverges at the larger angle, and the second is the nozzle exit, in which the divergence is the small. So this considers two kinds of scenario, that is divergence at smaller angle and divergence at larger angle. So the throat area, which is very much small, has the large divergence angle, and the throat area is also known as the suction part, and the last is the nozzle exit, which has the which has very small divergence angle. The main use of bell type of configurations is that it is very much low in weight, which enhances the performance and which gives a maximum performance. So this type of nozzles are better than the conical nozzle in terms of size and performance, and due to this they are highly used in rocket propulsion applications. So the third is the annular type of nozzle, which is a combination of ring nozzle, annulus nozzle, and also the nozzle base. So if we talk about the combustion which occurs in such kind of nozzle configurations, they are only generated on the ring area or the annulus area. And when it comes to the complexity, as I stated earlier, it is of greater complexity. So many engineers avoid to use such kind of nozzle in the configuration type. There are two major types of exhaust which are used in an annular type of configuration, that is outward exhaust and inward exhaust. If you talk about the outward exhaust, it falls under the category of reverse flow and horizontal flow. And if you talk about the inward exhaust, it talks about the spike type of nozzles. So basically, this both types, that is outward exhaust and inward exhaust, deals with the flows which are generally considered, that is reverse flow and the horizontal flow. Okay, so let's talk about rocket staging, which are then bifurcated into two types, that is serial staging and parallel staging. So if you can see in this left photo, that is of the serial staging, the rocket fuselage body that is shown before the staging, and the rocket fuselage body which is suspended and in which the straps are discarded at the first stage, it is shown after the staging concept. So if we talk about the before staging, it is a powered ascent flight in which the rocket lifts off from the original condition, and after staging it upper fires the nose part, and the strap is discarded at the first stage. So in this kind of condition, the discarded first stage is reused or reinvented using the data which is obtained after the discard of the first stage, but the upper stage continues to fire in order to complete the mission. And hence, in due to the serial positioning of the straps and the sustainers, this can be considered as the serial staging concept. Similarly, if we look on to the parallel staging, there are two categories, that is before staging and after staging. So if we look into the before staging concept, it is generally a power ascent flight in which there are two kinds of sustainers which are jointly placed on the left and the right side of the fuselage body of the rocket. After the rocket takes off, and after the first stage of the discarded flight, the sustainer continues the firing, whereas the straps are discarded at the same time of power descent mode, and they are retrieved or recollected and are used in the later process. In this condition, due to the configuration of the discarded straps on the parallel types, that is on the left and the right of the fuselage body of the rocket, this allows the condition to be called as parallel staging, in which the sustainer continues the firing part after the discarded straps are put on from the joint mechanism. So in total, we have covered that the rocket types can be classified based on the propellants used, and majorly there are five bifurcations of the propellants. The nozzle configurations are different based upon their shape and the size. It means that in order to put the nozzle in the working conditions, you need to focus on their shape and the size and the divergence angles, which are very much important from imparting thrust point of view. And the third is the staging of rockets, which is generally categorized into two types depending upon the release stage. So the serial release stage and the parallel release stage comes with the discarded straps, which can be retrieved ahead. Okay, thank you, and I'm open for questions if any. So you can put it in the chat box.
Thank you, Vani, for this wonderful presentation. Now, I would like to ask participants, if you have any questions, please feel free to ask your questions by turning on your mic, or you can also write your questions in the chat and we will read out the questions. Okay, so I think we already have a question from Dipan Sharma. Does it also contain a system with a common name, electric hall thruster?
So yes, if you consider the category of electric propulsion, it has the inbuilt device called the thruster device, which can be later fabricated if you want to have an extra thruster system, or if you want to have an additional put on extra thruster. So it comes on the later stages.
Well, we also have a few questions from our YouTube chat. So, Cosmicality have asked, what form of propulsion is used in cryogenic engines?
Yes, so if you consider the concept of cryogenic engines, which basically deals with the higher temperature and higher pressure inputs, so it uses the chemical property, and in such cases, nuclear core reactors are also considered.
We also have another question from her. Can the sodium water combination be used as rocket propulsion somehow?
Okay, so if you talk about the sodium water composition, it it needs to be verified that if the combination of sodium water, that is the how much amount of pressure and temperature can be obtained if we carbonify the kind of sodium composition. And as I said, that in solid type, carbonaceous grain is highly considered, so we need to look out the chemical properties, that what amount and at what pressure and temperature is the chemical operating. And after all, if you focus on to the operating conditions, it can be considered.
Okay, we also have another question from her. What is the most effective nozzle configuration?
Yes, so if I talk about the most effective, it is the bell type, because of the divergence angle and also of the suitability with the throat area and the divergence area at the nozzle. So there, as I mentioned, that there are two sections, that is throat and the nozzle exit area, which basically deals with the divergence angle of varying type, that is from smaller to bigger type, and hence due to the advanced and easy manufacturing of bell nozzles, they are highly considered.
Okay, so in the chat, Dipan Sharma have asked, out of the two nuclear thrusters or electric Hall thruster, which one is preferable for putting the satellite in low Earth orbit?
Yes, so if you talk about the low Earth orbit concept, it basically deals with the idea of orbital decay as well. So the intake geometries play here the major role. You need to consider the intake geometry first when you are putting the electric rocket in the lower orbital area, because there are certain kind of geometries which use the residual atmosphere gases which are available in the orbits, and they don't have a separate propellant storage. They only use the electrical and residual gases formation which are present in the atmosphere in the orbits, and they don't have a separate system of propellant, and so due to this case the intake geometry plays a major role.
Okay, so next, Harsh Verma has asked which gas or liquid we use in pressure chamber in liquid propulsion.
Okay, so if you talk about the liquid propulsion, both the types of category are generally of the liquid matter. It means that if you are using the liquid oxygen as a part of oxidizer, you can use kerosene in terms of fuel, which is in the liquid matter.
Okay, so I'll request participants to ask their questions. If you have any questions, please feel free to ask your questions. Okay, so we have got another question in our
Hello,
YouTube chat. Yeah,
hello,
sure.
sir.
Yeah.
Am I audible?
Yes, you're audible.
Ma'am, my name is Rishikesh.
Yeah, tell me.
I have a doubt. I'm currently
Yes,
pursuing my BE degree in mechatronics engineering. Can I do my master's in aerospace or aeronautical field?
yes, as far as if you have any kind of subject which relates to this aerospace engineering, you can opt for it, because you need to have a basic mechanical or STEM degree in order to pursue aerospace engineering.
Ma'am, we have some subjects in mechanical engineering only, not about aerospace or aeronautical engineering.
Yes, but the aerospace engineering is the subdivision of the mechanical engineering. So there are many subjects which are common in both the fields. So you can easily check the modules which are available on the websites and you can follow.
Okay, okay, ma'am. Thank you, ma'am.
Yes.
So we have another question from our YouTube chat. Prasad Kolhar have asked, which method of fuel can help us to reach Mars faster?
Sorry, can you please repeat which method of?
Which method of fuel can help us to reach Mars faster?
Okay, so if you talk about the most useful type of propulsion system, that is the liquid propulsion system, and the major use of such kind of system is due to the small storage capacity, because the liquid have higher fuel density, and in such cases the volume is reduced, and you can easily go on you can easily use this kind of configuration in order to reach timely and effectively.
We have received another question from YouTube. Someone has asked, what is the way of establishing the communication between a CubeSat and ground station?
Okay, so I don't have a brief idea about CubeSat, so I cannot reply to this question.
Yeah, surely. So next question we have from Bhavesh. The amount of thrust produced by the rocket depends on. I think he's asking about the factors on which the amount of thrust produced by the rocket depends on.
Okay, so amount of thrust which is produced totally depends upon what type of configuration you are using as a nozzle part. Also, what type of propellant you are using. So the major role is played by the propellant here, which helps the expansion of the whole propellant in the turbine section, and which helps in the release of the high imparting velocity gases. So it is majorly the work of propellant system.
Okay, so in meet we have received from Grishma C. Reddy, is there any limitation in serial staging and parallel staging?
Yes, if you consider about the types of serial staging and parallel staging, so in serial staging there is only one bootstrap, whereas in parallel staging there are two parallel types of bootstraps. So if you focus on to the higher missions and higher efficient missions, you can always go on with the parallel staging concept.
Okay, so Akash Sharma have asked if we want our rocket to return back safely after the completion of the project, which of the rocket propulsion is suitable for such operations?
Okay, so if you want to retrieve your rocket, you can only do one thing, that is you cannot retrieve the whole rocket, but you can easily retrieve the discarded bootstraps which I have shown in the serial and parallel staging concept. So you can use and choose accordingly of what kind of retrievation you are looking forward to.
Okay, so in YouTube, Cosmicality have asked, are there any new propulsion methods in making or being thought about which you might know?
Yes, as far as I know, currently there is certain amount of modification happening in terms of the intake geometries of the electric propulsion type. So the scientists are looking forward to work with the idea of reducing the intake geometry area and to use only the residual remains which are present in the atmosphere near to the orbital section. So it will eliminate the storage of propellant, and the propulsion system, that is the rocket, can go without any kind of propellant being used inside the matter. So so it will basically work on the intake and suction of the residual belongings which are present in the atmosphere. So this is the major recovery and major kind of discovery which is happening and which is being put forward to.
Okay, so in YouTube, Mannat Sadadiwala have asked, how does rocket fuel burn in space without oxygen?
Okay, so this is the type of non-breathing category. As I already mentioned, that rocket itself carries the oxidizer part with the storage capacity. So it falls under the category of non-air breathing engines.
Okay, so Prasad Kulhar was let us suppose our fuel is burnt to reach Leo. So from Leo to Mars, we don't have conventional propulsion. So in that nuclear will be so in that case, nuclear propulsion will be convenient or not, except the radiation factors.
Yes, so if you consider the type of nuclear core reactors, you always need to put forward the imaginations of how much the gas will radiate and how much the nuclear fission and fusion will react the whole procedure. So you cannot neglect the radiation factors, but yes, if you can consider this kind of nuclear core method, you can easily go, but there are certain kind of drawbacks as well if you take the radiation factor into consideration.
Okay, so Avinav Singh have asked, can you tell me something about photon propulsion?
Okay, so photon propulsion basically, like I don't have any brief idea about it, but I can tell you about ionic propulsion if you need to know.
Okay, so Alpa Sadadiwala have asked, what controls the thrust of the rocket?
Okay, so if you talk about the controlling part of the thrust, which it is highly dependent upon which type of nozzle you are looking. So if you want to know that the amount of thrust which the rockets impart at the end of the procedure, it is basically the working involved of the configuration of nozzle and the for example, if you consider the converging diverging nozzle, it highly depends on the divergence angle. And as I also stated, for the bell and the annular types, it resembles with the concept of the sizing and the shaping values. So you can easily control thrust by the type of nozzle you are putting forward to.
Okay, so Prasad Kulhar asked, what is your future goal in aerospace? If you want to share, you can. If you don't want to share, that's it. That's fine with us.
Okay, so yes, basically, I'm currently researching in electric propulsion, and this is one of my main dissertation project. So I'm looking forward to establish certain kind of propulsion geometries and useful varying intakes, and how I will carry it forward using the satellite terms and conditions. So yes, I'm currently planning to work as a researcher in rocket area.
Okay, so Dipan Sharma in Meet have asked, hi, what are your views on nuclear thermal propulsion, specifically fusion? Uh, how far is it to be practically used in missions, and what are the recent R&D in this going on nuclear propulsion? Yeah, that's a question.
So, if you practically look into the working format of nuclear thermal propulsion system, specifically if you're talking about fusion, it includes a variety of power sources and certain kinds of heat generating techniques. So, like if you look onto the practical aspects of using this kind of propulsion system ro- uh, into the rocket missions, it is not advisable to go far on a long mission using this propulsion system, just only because of the radiation which can damage your rocket or your space shuttle you are working with, and it can also it can also create unwanted damages and dents, which is not at all useful for the atmosphere, and it is harmful in the same way to the environment in which you are working.
Okay, so Chamandeep Singh have asked, what factors affect the acceleration of rocket propulsion?
The acceleration of rocket propulsion basically deals with the amount of compression the compression chamber involves, also the also the expansion of mixture of fuel and air in the combustion chamber. So it is a combination of both the compression and combustion chamber.
Okay, so we'll take our last question for now. Prasad Kolar asks, which books can you suggest for learning rocket science if someone want to build from scratch?
Okay, so there is a book named Rocket Propulsion Elements by George Paul Sutton and Oscar Bilbars. So it is the highly recommended book if you want to learn rocket propulsion elements from scratch. It enhances your basics from the starting of the modules itself. So you can easily go on. The name is Rocket Propulsion Elements.
Okay, I'm really sorry. I was having some internet issues. So, firstly, thank you, Vani, for this wonderful presentation and for this wonderful session. I am sure our participants have learned a lot from this session, and they have been also helped in moving forward with this subject in future. Secondly, I would like to thank all our participants for joining us today and supporting us throughout the session and helping us in conducting this session successfully. Lastly, I would like to mention about the our Hex-Star Universe regional uh, channel, which is where we launch live sessions on regional languages of India. So don't forget to visit that channel and learn about space science in your regional languages. And also, we will be starting with a internship project on CubeSat. So don't forget to join our project on CubeSat. I'll be putting the link for the form for registration in the chat now. So you can also fill up the form and join our internship project there. And with that, I think we'll be ending our session here for today. Lastly, I'd like to request everyone to turn on their camera once so that we can take a picture. Thank you, everyone. With that, we can end our session here for today.